Welcome to the 2021 International EMV Series Vehicle Walkaround. The purpose of this video is to outline the key components of the high voltage electrical system, including their location and function. Thank you for joining and welcome to the Woodbridge Product Support Center. Today we will walk around the 2021 International EMV Series vehicle and discuss the vital components of the high voltage electrical system. Let's get started. To begin, we will discuss the components located at the front of the vehicle under the hood. The High Voltage Distribution Unit, or HVDU, controls the flow of high voltage direct current to the high voltage power steering pump, high voltage air compressor, DC to DC converters, and high voltage cabin heater. The two onboard chargers accept external AC charging current from the charge port and convert it to DC in order to charge the high voltage battery packs. The 2-in-1 inverter inverts high voltage DC electricity to AC in order to power the high voltage power steering pump and high voltage air compressor. The Supervisory Control Unit, or SCU, monitors charging system operation and translates related messages for the VCU. The Vehicle Control Unit, or VCU, monitors the state of vehicle systems as well as controls the high voltage powertrain. There are two under-hood mounted surge tanks. One is for the cabin heater coolant system, and the other is for the power electronics coolant system. The high voltage power steering pump creates hydraulic pressure, which is used to provide steering assist. The high voltage air conditioning compressor circulates refrigerant through the air conditioning system. Now we will review the components found under the vehicle. We will start at the rear of the vehicle and work our way forward. The drive motor is powered by high voltage direct current, delivered by the Traction Power Inverter Module to drive the vehicle axle via a short drive shaft. The Traction Power Inverter Module, or TPIM, controls the supply of high voltage direct current to the drive motor. The S-box acts as a gateway for the high voltage batteries. The Battery Management System, or BTMS, contained within the S-box assembly, controls the function of the S-box. The Manual Service Disconnects, or MSDs, are removable fuses located on the S-box. When removed, the MSDs open the circuit between the high voltage batteries and the rest of the high voltage system. Note that there is still electrical potential between the battery packs and the S-box even with the MSDs removed. The High Voltage Distribution Module, or HVDM, controls the flow of high voltage direct current to the Traction Power Inverter Module, Battery Thermal Management System, and the high voltage air conditioning compressor. The high voltage battery packs are arranged in strings of 3 batteries wired together in series. There are 9 battery packs for a 3-string configuration and 6 packs for a 2-string configuration. Battery packs are mounted under the vehicle in between the frame rails. The high voltage cabin heater warms coolant for the cabin HVAC system. There are 2 coolant pumps located under the front of the vehicle. One circulates coolant for the cabin heater coolant system, and the other for the power electronics coolant system. The high voltage air conditioning controller is also located under the front of the vehicle. On the driver's side of the vehicle, we have the high voltage disconnect switch, 12-volt disconnect switch, and the DC to DC converters. The high voltage disconnect switch can be used to disable the high voltage control system. The 12-volt disconnect switch is similar to what is found on legacy vehicles and disables the 12-volt system. The DC to DC converters convert high voltage direct current from the high voltage battery packs. to low voltage direct current used to charge the vehicle's 12-volt batteries. We will now finish with the components found on the passenger side of the vehicle. The Battery Thermal Management System, or BTMS, maintains optimal temperature of the high-voltage battery packs. Circulated coolant is either heated or cooled based on the operating temperature of the high-voltage batteries. The charge port is the interface between the external charging device and the vehicle. This port accepts both AC and DC power supply. This connection style is also referred to as the Combined Charging System, or CCS. The onboard charging interface module broadcasts the status of the charge across the data link, controls the charge port lock, and controls the charge status LED indicator. The high-voltage air compressor generates air pressure used to power pneumatically actuated onboard components. This concludes the International EMV Series Vehicle Walk-Around. Thanks for joining.